Tech 1600. This is your lab and classroom for this semester. So come on in, and we're gonna go look around for a minute. All right. So we are. I'll tell you a little bit more about this space shortly. This is the space that I work in here at Cal State LA and ECST. And we're going to walk around the shop really quick. And that way you know where we are. Okay. And I just refurbished this lathe. I did it over Christmas break. It took me a little while, a little bit of money, but that's for us this semester. There's another lathe. I know some of you might not even know what I'm talking about yet, but we'll get there. And so here is the shop. Really welcome. And actually that's material for our that's the price. I'm not going to show you that. And that's material for our project. And okay, so good look around. And this is where I will be doing not going to do lecture. So I'm going to do short talks. So that's our whiteboard. And there it is. All right, so I'm going to see you at the whiteboard. Welcome. All right, so my name is Blake Cordes, and I'll tell you a little bit about myself in a couple minutes. Real quick, I prefer you just call me by my first name. It's Blake. I don't have a PhD, so no need to call me doctor, but actually please don't. And if you're uncomfortable calling me by my first name, which is Blake, Mr. Cordes is okay. I don't really like Mr., okay? And no need to address me as professor. Okay, just if you're comfortable, just call me by my first name, and it's Blake. All right. Okay, so this is Tech 1600. It's intro to metalworking, primarily the machine shop. All right, and this class is going to be pretty much 100% YouTube. All right, no Zoom and email, of course. So we're going to be doing email and YouTube. I want to, before I tell you about myself, about the class, okay, I want to run over a couple things in the syllabus. I've been teaching this class, I guess I'm either finishing up my 6th year now, or I'm in my 7th year now, teaching this class. I taught this class remotely last semester. I did some things right, and I did some things wrong doing this class, and we'll talk about the hands-on element as well a lot. Probably too much. I'll probably repeat myself a million times. I know it's a hands-on class, and there's no hands-on, so we'll get there in a minute, okay? Please read the syllabus. It's really quick. There's really not that much to it. Right away, let's just shoot down the syllabus, all right? So there's my name, there's my office. I'm going to say this a million times. When we do come back to in-person, if you are still on campus, I would love it if you'd come see me so I can meet you in person. I think that would just be so awesome. So please keep that in mind, and I will keep saying that often. My cell number is there. That's not my office number. That is my cell number. So I'm not going to write that on the board because this is going public on YouTube, all right? But it's there. Feel free to text me. Text me. If we need to talk, no problem. But but text me first. Let me know who you are. Like, you know, my name, your name, and text 1600, and I want to talk about this, or is this okay, or what? Feel free to text me. Office hours are here on the syllabus because that's a, you know, that's like a, what's the right word? That's the official business. But for remote, online, my office hours are 24 hours a day, 7 days a week. If you email me, I will probably get back to you within a couple hours. Really, okay? Obviously, if you email me at 4 o'clock in the morning, I'm asleep, okay? So I'm not going to get back to you right away. Or if you email me at 2 o'clock in the morning, I'll get back to you in the morning. But really, even on Sunday, if you want to email me on Sunday, I'm totally cool with that. So, office hours, all right. Let's see here. Just keep going. I'm going to keep going. Required text. There is no required text. But it is highly recommended, which you will see throughout this semester, that you get a book called The Machinery Handbook. We're not going to talk about it right now, but you will see that if you're really into manufacturing and machining, that you're going to end up buying the book anyway. Okay? So, let's see. Read the, like I said, read the syllabus. I'm going to pretty much go over everything on this list down here on the second page. It says topics covered. What I'm not going to be doing this semester, though, is probably welding. And I know, everyone's like, no, that's what I wanted to learn. That's what I wanted to learn. I'm not going to do welding. It's too difficult to shoot, and it's too difficult to explain what's really going on. And really, welding is, after you learn the fundamentals, I mean, you can learn welding for the rest of your life, but after you learn the fundamentals, it's really a lot of practice, okay? So we're not going to do welding, and we're just not, and we're not going to really do any casting. All right, so let's go. Obviously, safety stuff is so important, all right? And in the regular school year, like, I really go through safety, but what we're going to do, and what I've learned, because I did this last semester, is that when we talk about safety, when I introduce you to the machines, I'm going to go over the safety when I introduce you to each machine as we go. And then throughout, you're going to see, you know, I'm going to say, okay, what I'm doing here is like questionable maybe, or yeah, we're going to do safety as we go. And I think that you get more out of that when we do it that way, as opposed to me just like blasting out safety. Okay? All right, attendance. Your attendance is your grade. Okay? Now, okay. So we're going to see here, we're going to go to page 5, I believe. And on page 5, I have attached an amendment to the syllabus. All right. Here's the way this class is going to go. Everything is going to be on YouTube on Monday morning, sometimes Tuesday. On Monday morning, I am going to post a video I'm going to email you a link to a video. I'll have the video uploaded to YouTube before that, obviously. And in that link, you just click on the link. It's going to take you right to the video for the week. An attached file on the email is going to be a Word document with about 4 or 5 questions. All right? And you need to answer those 4 or 5 questions, you ready? By 5 p.m. on Friday. Here we go. So you're going to get an email. I'm going to write this. You're going to get an email. There's going to be a YouTube link. And then there's going to be attached Word document. All right? With 3 to 5 questions on it. That's it. That is it. All right? Your attendance is whether or not you get this back to me by Friday, 5 p.m. Okay? Now, on that Word document, you are graded as follows. You're graded on the thoroughness of how you responded to the questions. You're graded on your thoroughness. I'm not going to spell this right. Your thoroughness and how articulate you answer those questions. You are not graded on how well you understand. All right. Some of you might be going, huh? Well, this is a hands-on class. Like, I think that you need to be able to. You need the hands-on experience to really understand what I'm really talking about. I'm going to do a pretty good job of explaining and showing you and describing everything that we're doing, but I'm not going to grade you on whether or not you understand the material. I think that would be ridiculous. Okay? So, that's it. I'm just going to come straight out of the gate. There's no test. There's no final. All right? There is nothing but, I know, here it is, an hour-long to 2-hour-long video once a week. You're like, what? You've got 5 days, just about, maybe a little bit less than 5 days, to watch an hour or 2 YouTube video that's completely custom, made by me for you in the shop we just saw. Okay? You don't have to watch it all at once. You can spread it out through the week, right? If there are any questions about what I just talked about, if I didn't explain that well enough, email me, text me. I'm going to send out an email to every one of you Monday morning, maybe Tuesday, okay, with a YouTube link and a Word document with 3 to 5 questions. You have till that Friday, 5 p.m., to turn it into me. Email it back to me with the questions. All right? Okay, so how timely you respond will be your attendance. How thoroughly you respond to the questions will be your grade. Okay? There will be no point reductions for not understanding the content. It's right here on page 5 of the syllabus. Okay, you have that. All right. So enough of the. I think that's it. I mean, really, that's it. Okay. So now let's start having some fun. I think the content is a YouTube channel that I've created called Tech 1600. Now, I originally thought that I was going to make like a Tech 1600, second semester YouTube channel or something, but I've decided against that. I'm going to keep adding to the channel, and here's why. Last semester, I really went through some stuff in detail, and I'm not going to go through as much detail This semester we're going to have a little bit more fun, I think, than we did last semester. However, last semester was a lot of fun too, okay? And that's what I want this class to be. I want this to be the most stress-free class you have, okay? I want you to look forward to sitting down in front of your computer whenever you want to do it. Some of you do it, I know because I got the answers last semester at 3 o'clock in the morning, right? Some of you might do it at midnight. I want you to sit down and really enjoy watching this. I want you to develop questions. I want you to email me your questions. Blake, what the heck were you doing there? I don't understand. I want it, okay? In the normal semester when we're in person, I work with each and every one of you one-on-one. I will work with you until midnight if I have to, so you understand the content and what we're doing, all right, in the normal. But I can't do that now, so it's kind of important to me that you engage. If you don't want to engage, I got no problem with that either, okay? That's your thing, okay? That really is. And you're not going to not get graded for it either. If you turn in that Word document, and I know you watched the video, and I know, based off of how you answered the questions, by 5 p.m., you're going to get an A. Okay? It's that simple. So, in 4 weeks from now, don't email me and say, hey, what's my grade? You should know what your grade is. If you email me the questions, sorry, those are my keys banging up. If you email me the questions, you know that you're going to get an A. I'm not going to grade you if you didn't understand. You're not going to get points deducted if you don't understand. Basically, there is no grade. It's a check in my Excel spreadsheet, all right? Did you turn it in or not? You might get a check minus in my Excel spreadsheet if you answered all the questions with 1 word or like 5 words or something like that. And then at the end of the semester, if I see a whole bunch of check minuses, then you might get an A minus or a B plus. Do you get what I'm saying? Okay? This is stress-free, this is easy, and most important, it's really a lot of fun, and I am really, really kicked back. Okay? Alright, enough of that. I'm going to talk about myself for a minute. Like I said, my name is Blake. I am a technician here at Cal State LA in ECST. I've been here quite some time. I graduated from the Industrial Technology Department in 2008. They hired me as a technician when I was a student. So I've been doing this for quite some time. All right. Before we move into the machining, I have another role here at the college too, and that is I'm the technician for the hydrogen fueling station. Maybe if there's time in the semester, and near the end of the semester, I'll give you a tour of the station. Actually, that's kind of cool because I'll take you behind the scenes, and I'm the guy who fixes it, you know. I've been doing that since before it even opened. I was hired with a really good friend of mine, my boss actually, and to get that station going, and that was an incredible journey. We'll see if there's time. It doesn't really go with this class so much, right, like content-wise, but it is very interesting. Okay, so I make stuff. That is what I do. That's what I do from the moment I wake up in the morning till I literally am going to crash at my workbench. I'm a machinist. I don't like the term master machinist. I just love machining, and basically I love solving problems and making tools and all that kind of stuff, okay? And I'm a designer. I live in SolidWorks. I love it. I use it every single day, almost, and I use the shop every single day too. I have a shop at home. I have a wood shop at home, and where currently I'm working on my house, but I make stringed instruments. So I make archtop guitars, violins, cellos, electric guitars on the side here and there for fun, and that's what I love to do. So, and I love music, and before I get to the project, I like to make things that have to do with music too. Here at the school, I think one of my primary roles here is that I help students and faculty with their projects. From making it, designing problems, small questions, to actually just designing and making the whole thing, not for students, but for like research equipment, things like that. I've been doing it for a long time, okay? I don't know, maybe I'll tell you a little bit more about myself later. So, the big question is, what are we doing? Okay, what we're doing, and I will, in a few minutes, it'll come up in the video, I'll give you a rendering of what we're making. First, last semester we made a lap steel guitar. So if you are so inclined and want to, I left all the content up on the YouTube channel. So it won't get confusing, don't worry, you'll have a link. And like I said to you, I'm not going to go into so much detail because if you really want the material, you can go back to the YouTube channel, my YouTube channel for this class, or this class's YouTube channel, and watch those videos. They are kind of interesting, I think. That it was a learning experience for me. I had never done that before. Shot so much video. I've shot video and posted it to YouTube, but not like that. Okay, so I didn't get any new equipment. Yeah, I know, but I got good or better. I won't say good, but I got better at using the equipment that I have. I'm using a GoPro with my phone, so you know I can see what's on the. You know I can see the shutter or the lens on my phone. So throughout, you're going to see me with my phone all the time. I'm not on my phone. It's how I'm seeing what's on the camera. All right. Actually, the phone's right in front of me right now too. Okay. So what else do I have to say? We are making a turntable to play records. Yes, old vinyl records. That is what we're making. And it is not going to be easy, I don't think. And there's a chance that it might not even work. Yep. All right. I've made a couple turntables in my life in the past, and we're going to be doing a new one that I designed over Christmas break for this class. I don't want to do another guitar. That's already up there. You can watch that. That was a lot of fun. I think some students really enjoyed that. Some didn't care. I thought it was a lot of fun. We made a guitar almost entirely from scratch. Okay. Anyway, so we're going to make a turntable, and it's a lot of it is going to be on the lathe. Now I know some of you are like, I don't even know what that is, and don't worry, you will. And previously, when we were in person, the class, we made a hammer. We made a hammer handle. Okay, we made a hammer. We made a handle. All right, and then a head, right? Okay, and it primarily was done. Most of it was done on the lathe, and then the head was done on the vertical mill. I know I'm using terms that you don't even know they are yet, but don't worry. The reason for that is that I've found that the lathe is the most fun, and especially for students is the most fun to use too. So I've designed the lab when we are in person to be lathe heavy because that is the most fun, I think, and it's more forgiving than the mill as well too. Okay, but we still need to use the mill, and we still need to learn how to use the mill as well. All right, so I am going to show you the turntable.
Here it is. The brass little guy up on top there is a clamp. That's a weight, actually, and it's going to weight the record down onto the platter. And then the platter is that 2-inch thick acrylic, and it's been screwed to a aluminum piece of aluminum disc down the bottom. And we'll move on here. I have a section view coming up. So what's going on actually in this that the helix area, that spiral, that's the spindle, and it's inside the bearing base, and it's floating on 2 magnets, and that helix, that spindle, is going to pump oil up inside the spindle, and we'll see in a moment. I have another section view coming, so we can take a look at that. Yeah. All right, so you can see the 2 magnets, and then there's the oil pump helix, and then it's going to pump oil up to the top, and then down that small hole off to the right is going to the oil will return back down to the sump. So it's actually it's tricky. It's pretty simple, but yet it's pretty tricky, and the tolerances are going to have to be really tight for this to work just right. So there's the base, and you can see the oil return hole. You see one of the magnets, and then yeah, there's an O-ring groove to keep the oil from leaking, and then now I have some animation so you can see that. So here it is spinning. It's, like I said, it's floating on 2 magnets, and we're pumping oil up that helix to lubricate the bearing. So later on as we go, don't worry, I'm going to explain all these parts in much more detail as the parts come out in drawings. All right?
Real quick, I forgot to say a couple things back in the intro to the class. Number 1, all right. If anybody has any problems accessing the internet or a computer, or any problems with YouTube or email, call me. If you can email me, send me an email. I will do whatever I can to accommodate you, okay? Really, I'm serious. So if there's any problems like that, any technical problems like that, please let me know, and I will do anything I can, okay? The other thing I needed to talk about that I didn't talk about was the hands-on portion. Yeah. Some of you might be wondering, well, I took this class, am I going to be able to use the makerspace, or am I going to be able to use the shop? The answer is yes and no, okay? I don't know if there is anything in line yet in areas like the makerspace to streamline students that have taken the class and then they just need a little bit of hands-on experience and then get you right into the shop. I don't know, okay? I hope that we, including myself, will be working on something like that when we do come back. But this is a hands-on class, and the really awful part about remote learning and this hands-on class is that you don't get any hands-on experience. And I'm just going to come out and say it. You're not going to get the hands-on experience with me. I absolutely love showing you guys how to use the equipment and the machines one-on-one with me right next to you and doing it. That hopefully we'll configure something out, okay? But I have no promises. There's nothing in the immediate schedule for that, okay? Now there is a benefit of this being an online class, is that the stuff that I'm going to show you, the techniques, are going to go way beyond what you would get in normal Tech 1600, okay? I'm going to show you things that I wouldn't, on purpose, show you in lab. Because I would want you to be more focused on the fundamentals, and we're gonna really do it in this class this semester. Okay, indicators, measuring devices. I mean, you're gonna really know what it's like on the machine shop floor. Okay, if you watch the videos. You really will know what I do, okay, and you will have the knowledge, not necessarily the experience, but you will have the knowledge to really make some cool stuff, okay. So that is the benefit. All right. That's pretty much it for the intro and for the project. Now there are some things we need to do lecture wise before we get into the shop, and I want to get in the shop right now, okay? But for you to understand what I'm even talking about, there are some things we need to go over, and I'm going to go over the basics right now, and we're just going to get started. Yes, I drink espresso throughout the day, so just get used to it, okay? I love it, and that's just what I am. So you're going to see that. I know it's not the most professional thing to do, but that's how I roll. All right, so let's get started. We're just jumping right into it. The easiest way to get started on some technical terms and get a relationship going with tooling and materials is to start with one of the most fundamental tools that we have, and lots of you have it at home. This is a drill bit. Okay, this isn't that big, but it's not small either. Here's a smaller one, and let's talk about drill bits for a minute, because what's going to happen when I talk about the terminology with drill bits and other materials is all that terminology and all that stuff is going to cross over into into the other tooling and machines. Okay, so I'm going to draw a drill bit here really quick, and we are going to take a look at that. And there is a possum coming into the shop. Excuse me. Okay, that was fun. All right, so let's go back to this. Okay, so here's our drill bit. All right, and what we're going to do here is we're just going to analyze a couple things. All right, and I'm going to give you a couple examples. On the drill bit, right, this is the tip, okay? The spirals along the side, all right, that's, those are the flutes, okay? And then where there are no flutes, where it goes straight, this is called the shank. This is called the shank. Okay, this stuff's important, guys, all right? Because this is going to really establish a lot of, and when we get more advanced, it doesn't change that much, okay? By understanding these simple fundamentals, they really translate over into more advanced tooling, okay? And it's much easier to understand. There's not a lot more, okay, really. So on our drill bit, right, this is the tip. These are the flutes, and where the flutes stop, this is the shank, okay? Now, what does the cutting is the tip, all right? These flute edges, they're sharp, yeah, but they don't do the cutting, okay? What does the cutting is the tip. The flutes are there to eject the waste, okay? So as we drill into a piece of material and we create waste, okay, that waste needs to go somewhere, and where that waste gets tossed up and out of are these flutes, and then it piles up, right? Like you drilled a hole into a piece of wood. That waste, believe it or not, the waste, whether it's wood, metal, plastic, or anything, is called a chip or chips. Okay, they're called chips. So when we drill in the metal, and the waste that comes out of the metal, that's called chips. That is the technical term, okay? So, we're going to be, chips, we're going to be saying that here just all the time, all right? Now, the shank is where we hold on to the drill bit, okay? So other types of tooling, which we'll get into next week probably, they're going to have very similar function. They're going to have a tip, they're going to have side helix or flutes, and a shank, okay? What we don't want to do is grab onto the flutes, because if we grab onto the flutes, it's going to get weird, and when we spin it, right, the drill bit spins, right, it's going to be all right, all wobbly, okay? We always grab on to the shank, always. Never grab onto the flutes. For those of you who have, used drill bit before with metal, you might have been inclined to try and enlarge your hole with the flutes, and you have them, you got your, right? Well, for those of you who have tried to do it, was the hole round anymore? No. Okay? The flutes are not there to cut with. We've all tried it, we've all done it, or if you haven't done it, don't even bother. Only an emergency, like trying to get your car out of a ditch or something. Look, it cuts with the tip, all right? So let's take a look at something here real quick. The tip angle on a drill bit that you, say, buy at Home Depot is 118 degrees, okay? And what I want, and the reason why I start with drill bits is because all this information, like I keep saying, translates over to other tooling and cutting devices. Doesn't mean that it's 118 degrees on the other one. But the reason why those angles I'm going to explain right now, that's what I'm going to explain is why these angles are on other tooling as well. All right? So why is it 118 degrees? Well, let's take a look at a drill bit that has a really steep point, okay, versus a drill bit that has not a steep point, okay, relatively flat. And as you can see, 118 is in the middle here somewhere, okay? Just bear with me. When we're drilling, and you have, a portable drill or a drill press, okay, it takes a certain amount of force, or what's properly known as pressure, to drill that hole, okay? So if we look at this drill bit, okay, we can see that the surface area here where it cuts is a lot greater than, say, on the flatter drill bit, okay? So this drill bit is going to cut more, so it's going to have less pressure, okay? Some of you might be going, all right, nope. That's not necessarily what we want, all right? That's good, because if we had to drill 500 holes into something, the operator wouldn't get worn out, or the machine would have less fatigue on it, okay? These are all things that we're going to work into, don't worry, but I'm just going to start to bring them in slowly, okay? We care about machine fatigue and operator fatigue. We care about how long this drill bit stays sharp, because in the manufacturing world, this drill bit is what? Money. All right? Money and it's time, okay? To change the drill bit and things like that. So we really care about that stuff. So this requires less pressure, but here's the drawback, all right? As a drill bit with a steep angle like that starts to go through material, it wants to go crooked. And what that does, going crooked, the term for that is it wants to wander. All right? And two things. Well, first, if it wanders too much, eventually the drill bit is just gonna break, right? It's just gonna break. The the second obvious, the more obvious thing is that you're not going to have a straight hole. So we don't want that. All right? Now, a flat drill bit, trust me, I'm going somewhere, requires more pressure, so more fatigue, right? Okay? But guess what? It goes really straight. All right. So what they, and I'm going to get there, have done, and I'm using the drill bit as an example because it's so fundamental, on every tooling, just about every tooling that exists, all right, is what I like to call they've tempered it. What do I mean by that? They've tempered this angle. They've come up with a balance. They've said, and I'll get to who they is in a minute. They've said, oh, okay, well, we don't want there to be too much pressure, but we want it to go straight. So they have come up with 118 degrees as their standard twist drill bit. I'm sorry, I didn't write that down. This is called a twist drill. Okay? And its standard is 118 degrees. Now, who is they? Because I'm going to be saying they all semester. Real fast, real quick. This is not a history class. All right. The first Industrial Revolution happened around 1800, roughly. It happened before that, 1780, 1790, went on to 19th. I'm just going to say, okay, like I said, it's not a history class, around 1800. Primarily that was textiles. So that was looms. It was for making fabric. That's what textiles are, okay? At the time, nuts and bolts existed, but each nut and bolt was handmade, like with a file or some sort of pulley-driven something, right? And they went together. So, Benny couldn't walk down the street to Joe and say, hey, you got a nut? Because, right? That nothing, it wouldn't fit together. It had to be each nut and bolt went together individually. Okay. So one of the huge benefits of the first industrial revolution, which was in primarily Europe, but we can get more specific and say England or the UK. England, UK, and went all over Europe, okay, was a term, and it's so important, interchangeable. Okay? By making parts and fasteners interchangeable, it really set the industrial manufacturing processes to just a whole nother level, okay? Huge deal. I think you understand. I mean, if you use the nut and the bolt as an example, you're like, whoa, right? Okay, really cool, okay? But there were no standards about, but like I said, this is not a history class, I just want you to get the principle. It wasn't until the second industrial revolution that we really started to see standards come. And that was in like the 118 degrees. In the second industrial revolution, which happened in the USA, engineers, machinists, manufacturing engineers, and scientists got together and they said, we need to develop these standards. You got to realize too that things like thermodynamics, they they were out there, but they weren't like proven and totally published until early in the 1900s. I know, that's not that long ago, so it was like 100 years ago. So when I'm talking about they, who's they? They are the factory owners. They are the scientists, the manufacturing engineers, and the machinists. All got together and they came up with standards. And it's really important to understand that they just didn't, pull it out of the air. They had experience from hundreds and hundreds of years of the first Industrial Revolution. And now we're moving into the second Industrial Revolution, and then World War I hits. Okay, I'm going to stop there. I think you get my point. That's who they are. The Machinery Handbook, okay? I think, don't hold me to it, but the machinery, no, I'm not even going to say. It was around 1900. The first edition of the Machinery Handbook was, it's in your syllabus, but it's the Machinery's Handbook. Everything about manufacturing, everything is in that book. I have at home, next to my computer, I have a bookshelf. I don't know, maybe 50 books in there, maybe more, of manufacturing books and how-to books, woodworking, metalworking, sheet metal. I need to get rid of it. I think I said that last semester too, the same intro, and I haven't yet, because I really only use the Machinery Handbook anymore. Really, I don't use those books anymore. I need to donate them. Maybe I could donate them to Senior Design or the Makerspace. But I use the Machinery's Handbook, all right? Next, I'm going to get there in a minute. On my computer at home with SolidWorks, designing complicated stuff, I've got two things. I've got the Machinery Handbook, and I've got this. This is a drill and tap chart, okay? See that? All right. For right now, for today, ignore the tap part. I just want to talk about drills and drill sizes because, like I keep saying, all this information translates over into all the other tooling. All right. So we can see here on this drill chart that at 80, a size 80 drill is the decimal equivalent is 0.0135. Okay, that's pretty tiny. They actually go tinier. And then as the number gets larger, the drill bit gets larger. Like wire gauge for wires, electrical wires. When we reach 1, where's 1? It starts over with letters, A, okay? And then once we reach Z, it goes into fractions. Now the whole time, it's always interlaced with fractional drill bits too, all right? So that tells us something right off the bat, that there are 3, there's more, but there's 3 common sizes for drill bits, okay? And they are known as number, or wire size, letters, and of course, the all familiar fractions. Okay? These are the drill bit designations. When you're designing something, and we'll talk about this again and again, and you're in SolidWorks and you make a hole, or you're designing something on paper and you make a hole and you call out that size of that hole and it's not on this chart, It can be done, okay? But it turns into an expensive nightmare, all right? This chart, like I said, what's next to my computer with SOLIDWORKS at home and in my office here at work is a machinery handbook and a drill chart, all right? All the drilling, all the hole diameters, they come off of this chart, okay? This chart came from the Second Industrial Revolution. You know who I'm talking about. The factory owners, the machinists, the scientists, okay? They all got together, they tempered everything, they balanced everything out, and here it is, all right? Okay. I think I made that pretty clear. All right. When we're drilling into something, we need to think for a moment about, there's lots going on, all right, if we were to really analyze it from an engineering standpoint. But from a practical standpoint, there's two very important things going on. In order for the drill bit to cut, it has to do what? Spin. Right? That's how it, right? And if it just sits there and spins, are we cutting anything? Nope. We have to what? Move it into something. All right? So just about every cutting tool, period, operates on that principle. That's why I like to use the drill bit. All right? Now, so those two motions are what's known as feeds and speeds. Okay. You guys, right now, this is everything, right? I mean, this is how you are successful in the shop. Whether it's, I wouldn't just say the shop. You're out there fixing a fence in the rain. This is how you're successful. You're making a nuclear reactor, a particle accelerator. This is how you are successful. All right? So we had those two motions. We had this spinning, and we had this spinning and moving. This spinning spins at what we would call an RPM, right? So that's rotations per minute. Okay, we all are used to that one. Now this is going to be moving for right now linearly, okay? Okay? And so its feed rate is going to be something like inches per minute. Well, we could do, let's do this. Inches per second. Feet per minute. This is what's known as feeds and speeds. Now there's an equation for this, and it's very simple. I'm not going to give it to you right now. I just want you to maybe rewind the video if you need to, but just sort of wrap your head around what's happening here. We want to drill a hole. We want to cut wood. We want to use anything. You want to use a circle saw, right? The circle saw, right? The portable circle saw, that blade's spinning. It's spinning at a certain RPM, and you're pushing it and that's your feed rate. The drill bit's spinning, and it's in the drill, and you're pushing it, and that's its feed rate. All right? And in machine shop land, that's what's known as feeds and speeds. This, I cannot stress enough, is the name of the game. Period. All right? Now, what determines our feeds and our speeds? That, like, oh, you're like, great, Blake, and I know that, but what's the big deal? All right. It's actually pretty simple. It's a couple things, but primarily two things, okay? It's going to be the material. And the size of the tool. Now we're getting somewhere, okay? So, when I explain this or teach this, this is how I teach it before we go into the formula, okay? Because then it's going to make a lot of sense. The bigger the tool, the bigger the drill bit, the slower the RPM. The harder the material, the slower you go on everything. RPM and feed rate. Sorry. And feed rate. Slower RPM and feed rate. And then guess what? It's the exact opposite of everything else. So if the tool is smaller, the RPM goes faster, and the feed rate is faster. Make sense? The softer the material, the faster the RPM, and the faster the feed rate. If I have a piece of wood, let's take these drill bits, all right? Is wood hard or soft? Some of you might be saying, well, oak's pretty hard. Oak actually is pretty hard. Walnut, maple, that's pretty hard. But for the sake of conversation, let's say wood's soft. Okay? So let's identify. We got wood. All right? And it is soft. Okay? That's going to say what? Faster feed rate, faster RPM. But I've got a big drill bit. What am I going to do? I'm going to slow everything down. Alright? And I know some of you are like, this is so boring. Guys, this is the key. Actually, this is the key to life. Slow down. Slow everything down. Alright? You slow it down. If you slow it down, you're not going to generate heat. You're going to reduce vibrations. I'm I'm getting ahead of myself. We're going to talk about that because those are the enemies. Heat and vibration. All right. Now, if I had a small drill bit, what am I going to do? I'm going to speed everything up. Speed up. Yes. Except in reality, you're still going to have a moderate, and I'm just going to, I don't know, I'll draw two arrows, like moderate feed rate, okay? In reality, most of the time, unless you're on some really big machines or CNC machines and things like that, automated machines, you're always going to have a moderate feed rate. If you push too hard or go too fast, even a drill bit this size, it's going to break. It's physics, okay? So, for the time being, that's the way we're going to think of it, but in reality, we're always going to have a moderate or slow feed rate, okay? All right, that's reality. All right, okay. Last thing I want to do before we're done for this week, actually, I'm going to go to the class intro, is I just want to identify a couple different types of materials and whether or not they're hard or they're soft, okay? So let's, I'm going to write a chart here. I'm going to say soft materials and hard materials. All right? So let's take a look at that. So we've got wood, right? Wood, plastic. I don't know, think of some other soft materials. Rubber. All right. Now I'm going to start to go. Aluminum. Aluminum is soft. Okay? Hard materials. What's hard? Steel. Steel is hard. Stainless steel. Stainless steel is really hard. Okay? Iron. Titanium. We can go on and on and on. We can go on and on and on with this list forever. But I'm going to stop there. You get the idea, right? What's kind of weird though, all right, is there's some materials that fall in the middle, all right? And I kind of treat them on the soft side. And if there's other machinists out there, and I'm going to say this all the time, they're going to be like, no, he's wrong. Your thing, man. Trust me. I've been doing this a long time. You kind of got to play with it a little bit, but you're going to have like cast iron. Cast iron, that's kind of in the middle. Brass, not all brass. There's some brass that's pretty hard, and there's other brass that's sort of soft. It's in the middle, right? Alloys like brass, so copper falls into there. Other things are kind of in the middle. We are going to be, for this semester, there is some aluminum. Last semester there was a lot of bronze and brass and aluminum. Your project usually is aluminum because it's soft and it's forgiving, okay? I think a lot of the material this semester is going to be stainless steel. And I know people are like, Blake, are you crazy? And I'm going to talk about that in a second. Not me being crazy. We're going to have some plastic, we're going to have some aluminum, and we're going to have some brass. All right? And brass. So those are the primary materials for this semester. There will be probably some other ones too. Okay. But that's, the stainless steel aspect. What is machine? What is machine? Machine. What is it? people think of machining as cutting metal. Machinist. Brrr. Machinist. No. Okay? All that is so wrong. Okay? So there's what machining is using a controlled mechanism to cut or form a material. So basically, it's using some sort of controlled mechanism to manipulate a material. That is what machining is. If you use a table saw, like for wood, that is machining. If you are using your portable drill and you're drilling a hole, that you are machining a hole into it. Okay? It can be plastic, wood, carbon fiber, you name it. Alright? That is what machining is. What about machining? And I will talk more about this later. But I want to end something right out of the gate. The gentler you are, the more that you think about what you're doing, the better your project's going to turn out. So that whole burliness, machinist thing, that is a stereotype, and that does not belong in the machine shop, period. I can't stand it. It needs to go away. It's actually about being gentle. Machining is about solving problems. I have a whole lecture about that. Well, not lecture, but a whole 5-minute discussion about that. That's what machining is about. All right. Have a great week. Any questions, email me. See you next week.